Yeah, good morning everyone. In the last videos, we started a new batch on data structures and algorithms with Python. Data structures and algorithms with Python. So the title of the course is Data Structures and Algorithms with Python and DSA with Python. This is the batch 5. Successfully, we completed 3 batches and evening one batch is going on, and this is nothing but a 5th batch what we have. And the timings of this session is, sir, we finalized the timings. It is from 7:15 a.m. to 8:15 a.m. Okay, so 7:15 to 8:15. So Monday to Friday, these classes will be there. And please make sure, sir, weekend classes also will be there. You have to adjust your timings so that we can take the classes on weekend also, but not on every weekend. Alternatively, like that, we will plan. And the duration of this course is a total 45 classes we are going to spend. And the fees for this batch is 1,500, where you are going to get live classes plus recorded videos for 6 months access, and also you will get running notes. So if you want to make the payment and if you want to get registered, you can contact to this number. And the syllabus, all these things I explained in the 2 days demo sessions. And we have seen some programs also. So for the demo purpose, just I explained a few programs. And even yesterday, I explained what is mean by n-queens problem, how this n-queens problem is going to implemented. Of course, the coding part I didn't covered, but I explained at a top level what is the problem, how you can able to solve that problem. Sir, in today's session, just I want to give some idea about linked list. Okay, linked list data structure. See, there is one special data structure is there with name linked list. Just I want to give introduction for this. So linked list means I can say the word, it is nothing but a collection of objects, something like a list only. Okay, internally in our Python, list is implemented by using linked list concept. In the background, the story behind the list is nothing but what? Linked list only. And do you know one more point? Sir, this linked list, I mean, in other languages, we have array concept is there. Array means collection of similar type of data, and it is always fixed in size. So there are n number of problems are there with arrays. To overcome that problems, we are moving for linked list. Okay, in other languages, but here list itself is backgroundly supporting linked list. But since we are discussing about data structures, as a part of data structure theoretical part, we need to cover this. Collection of objects is called as linked list. Sir, instead of the word called objects, I am going to represent one more name, which is nothing but collection of nodes. Okay, sir, we can also use the word called collection of nodes. Sir, now you can see what is mean by node. What is mean by node? Sir, very simple. Node means it contains, it contains, it contains. So, uh, 2 fields or 3 fields like that it can have. So if it is having 2 fields, then it is called as single node. Single node means it is going to have data field and so pointer field, which is pointing to the next node, next pointer pointing to the next node. If you take a double node, it is having 3 fields. One is a data field, which is pointing to the next node, and a previous pointer also will be there, which is pointing to the previous node. Like that we have. And we have single linked list is there. Okay, so collection of single nodes, in short form it is called as SLL. And a double linked list is there. Okay, so in short form it is called as a DLL. And circular single linked list will be there, so which is called as a CSLL. Okay, and also double linked, sorry, double circular double linked list is there. So which is called as CDLL. Like this, we have different types of linked lists are there. Of course, we are going to see the implementation for each and every program. Okay. Sir, diagrammatically, if I want to represent a single linked list, how we are going to take? Very simple. We are going to represent a single linked list in this style. So where we are having only two fields, this field is called as what? Data field, and this field is called as next field, which is pointing to the next node, which is pointing to the next node. Okay. So next we are going to have one more type of node where you will have three pointers. So what is the name of the first pointer? This first pointer name is called as a previous node, previous pointer, which is pointing to the previous node, and this pointer is called as a next pointer, which is pointing to the next node, and this pointer is called as what? Data pointer, to hold the data. Of course, in detail how it is going to work, all these things I will explain with the help of program. Not in today's session. Linked list chapter is there, right? There I will explain. But for your understanding purpose, today I am going to take one single linked list and I will demonstrate one simple piece of code how the single linked list is going to work. Sir, everyone please confirm, is the concept is clear up to this whatever I covered? Theoretical knowledge?
Yes, sir.
Yes, sir.
Clear, please confirm.
Yes, sir. Yes, sir.
Now, sir, just I want to explain some two operations on linked list in today's session. What is the first operation is display. Okay, displaying elements in single linked list. I have a single linked list is there. I want to display the elements. So let us first take the diagram how the single linked list will be. For example, consider this is nothing but the first node what we have, and this is nothing but second node what we have, and this is nothing but the third node what we have, and this is nothing but the fourth node what we have, and I'm going to combine all these nodes. Sir, first node is connected to the second node is connected to the third node, and the third node is connected to the fourth node, and the fourth node last field is nothing but what? Null. Like this we have, and this is a special pointer which is always called as a head node. Okay, and the last node is always called as a tail node. Like this, we are going to take two special pointers. One is a head, another one is a tail. Okay, coming to the data, let us take 10, 20, 30, 40, like this we have. Now we have to write a code which is going to display each and every element present in the linked list. Okay, I want to write a code to display each and every element present in the linked list. Now see how I am going to write the code. Sir, very simple, sir. I am going to define a function. Of course, it won't execute, just for your understanding purpose, I am telling. So display function is there. Okay, in this display function, do you know I'm going to take temporary node is equal to head. What is the first statement that we have taken? Temporary node is equal to head. Suppose if temporary node is equal to none, then I can print the message saying single linked list is empty. We can't able to display the elements. Okay, so means what? The first node is always pointing to the head. I'm taking one temporary node to point to the head. If temporary node is available, that means linked list is existed. If your temp is pointing to none, then what is the meaning? Linked list is not existed. In such cases, we are displaying a message saying linked list is empty. But as of now, this temporary node is pointing to the which node, sir? It is pointing to the head as of now. Okay, so temp is nothing but a head. Sir, now if condition is fail, now I am going to write a loop. Array, can you please cross check is a temporary node is not equal to none? Yes, because the temporary node is pointing to 10, which is not equal to none. Then we are going to print, so temp dot data, and we are taking temp is equal to temp dot next. Okay, observe these two lines. Sir, print of temp dot data. What is a temp dot data? It is nothing but a 10. Then what is the next instruction, sir? Can you please look into temp dot next? This is the temporary node. Its next node is pointing to 20. Okay, that node will become temporary node. From now onwards, this is the temporary node, not this one. Have you observed, since it is written inside the loop, again the loop is going to start. Is a temporary is not equal to none? Yes, content is there, which is not equal to none. So it will print the data 20 and temp is equal to temp dot next. Okay, so from now onwards, my temporary node is pointing to 30. Sir, is a temp is not equal to none? Yes. Can you please temp dot print temp dot data, which is nothing but sorry. So which is nothing but 30. Sir, next temp is equal to temp dot next. From now onwards, my temporary node is pointing to the 40. Sir, is a temp is not equal to none? Yes. Sir, can I print temp dot data? Yes, 40. Okay. Sir, next time what will happen? Your temp is pointing to the none. Your temp is pointing to the none. Sir, while temp is not equal to none, yes, it is not. It is equal to none. So it will break the loop. That's all. Sir, can I say these are the elements present in the single linked list? Yes. Like this, we can write the code. Sir, you may have a doubt. What is mean by node? What is the structure of node? Where you defined this head? Where you defined this tail? All these things. Don't worry. It is a small piece of program. That's all. Okay. Around some 200 lines of code is there. In that, just I have taken only few lines of code. That is which operation I am trying to explain? Display operation. Still, we have some content that we will discuss in the regular class because it is a demo session, right? That's why I am giving at a top level what is happening. Sir, everyone, please confirm. Is the concept is clear, friends?
Sir, I have one question here.
Yes, you can
Uh,
ask.
so you have written while temp is not equal to none, print
Hmm,
temp dot data. So
hmm.
question is, data is not defined here. So won't it throw an error?
No, no. Sir, I am telling this node structure is somewhere we defined. Like we are going to use the class called node. Okay. So in this
Okay.
class, there will be two fields will be there. One is nothing but a data. Another one is nothing but next. This is the structure which we will define in the class. Okay. Now it is
Okay.
representing temp means what? So temp is nothing but one object for this node class.
So we've
Getting the
just created a variable called temp here.
yes, temp is the object for which class? Node class. Now, by using
Okay.
this object, can I access data? Yes. Can I access next? Yes. Got it? So
Yes,
that's
sir.
what I am trying to explain. Don't go in detail. We will see later about all these things. Just a diagram and how the control flow is going. That alone you have
Okay.
to focus. Got it
Okay,
right?
sir. Yes, sir.
So, sir, I have one doubt.
Yes.
Yeah, so in the next, what will be there? I mean, is it will be the object or
uh,
the purpose of
object
the
only, object only. Here I told, right, for example, if you take node class, assume I am taking n1 and n2. So n1 will have some data field, right? Got it? N1 will have some data field and n2 also will have some data field. So which is nothing but a 20. So by default, n1 dot next field is always none. So n2 dot next field is always none. This is the general syntax. But if I want to consider this one as n1 and this one as n2, n1 next field is what? N2. So n1 next field is nothing but n2. Like this, the nodes will be connected with each other. Got it? And
sir?
data is what type of data? Integer or floating point, anything. Next is what type of data? it is representing again a class node, something like in C language, we have self-referencing structures. In the same way, we are going to define here. But we don't have any concept called data types in Python, right? That's why directly we can. Got it?
Yes, sir.
Yes, please confirm everyone. Is the concept is clear?
Yes.
So when you say pointer to the next node, it means it stores the address of the next node, is it?
Yes.
Okay.
But in C language, we can represent manually this address. But here there is no special operators for that. That's why directly it is going to hold the next object. Okay.
Okay, sir.
Any doubts?
So how the none is defined?
See, I think you are new to the Python programming. Do you know about none? Have you heard about the word called none?
No, sir.
Okay, no problem. None means so no object. Suppose if the value of x is equal to 10, it is having some integer value. If you take x is equal to none, no object is associated with this. The people who are coming from other language background, can you please look into this? It is something like null in Java, C, C++. Got it?
Yeah. So none will define, is it? For example, x will define x is equal to none. Is it?
Yeah, none is not required to define. Directly by default, we have a keyword is there called none. Directly we can write. Sir, all your doubts why you are getting is because I have written only sample code. I have not taken the complete code. That is the reason why you people are getting the doubts. Once if you see the complete code, you will get clarity. So, but of course, I don't want to make you confused because so many queries are coming. That's why I will show you the complete code. Just don't ask me to explain that complete code. Just have a look once on that code. Okay, so that you will get at least some idea. Okay.
Yeah.
So that all your doubts at least SAR will explain in future, like that you will get some confidence. Otherwise, so with half-minded, you can't go. Okay.
Yeah.
1 second, I will show you. This is the thing which I explained for the previous batch. From this, you will get some clarity. Just I have zoomed in. You can see, sir. Sir, have you observed here? Class node is there. DEF underscore underscore INIT underscore underscore data. All these are object oriented terminologies. The data field, whatever, while creating the node, you will give some data, right? That will be assigned to the data field. And the next field is always pointing to the none. Next, whenever you are creating the first node called N1 is equal to node of 10. So a node will be created with content 10 and the next field is always pointing to none. Next, N2 is equal to node of 20. N2 dot data means 20. N2 dot next field means none. Now I want to connect this node. Sir, N1 dot next field will become N2. Now if you ask N1 dot data, it will print 10. N1 dot next dot data, that means N1 is representing 10. N1 next node is 20. It's a data I'm asking. Have you observed? N2 is not required. Like that we can work. Okay. So whatever code I explained previously, sir, it is something like this. Displaying the content of the nodes present in the single list. I have taken print list function. As you can see, temp is equal to initially head. If temp is pointing to none, linked list is empty. Otherwise, we are going to check temp is not equal to none. We are going to print that data and temp is equal to temp.next. If you call this a function, sir, previously you can see we have taken something like that. Head is equal to node of 111. Head dot next is equal to node of 222. Head dot next is equal to node of 333. Head dot next is equal to 344. Head not So 4 next is equal to 555 like that. So 111 next field is 222, next field is 333, next field is 444, next field is 555 like that we have. Now if you ask a print list function, simply it is going to print the content in this style. Got it? At least your 50% doubts got clarified, I think so. Yes, please confirm everyone.
It's clear, sir.
Clear, sir.
Right. This is nothing but the elements present in the single linked list. Now, maybe if you are not going to confuse, I will try to do one operation, one method I want to demonstrate for you people. Something like insert at last. Okay, insert at last. I will write code for this. Sir, already I have a linked list is there in this style. This is nothing but my linked list what we have. Sir, now I want to add I want to add a new node. Okay, let us take that node is nothing but something like 50. So what is the content of the node? 50, and next field is as of now it is pointing to none. So consider this new node name is nothing but something like new node. In short form I will write NN. NN represent new node. Sir, I want to add this new node. Okay, I want to add this new node. So at the end of the linked list, how I can able to connect? Sir, one theoretical thumb rule is there. If you want to connect two nodes, so the first node should be associated with some name and the second node should be associated with some name. If these two are having names, we can able to connect easily. Sir, now how to connect these two? What is the code that we have to write? Sir, can I say already we have tail is there, right? So tail dot next field will become new node. Can I write this simple line so that what will happen? These two nodes are going to be connected. Sir, is this formula, is it clear for you? Please confirm.
Yes, sir.
Okay, but directly we can't write this line. We have to follow certain rules and regulations. What are those rules and regulations? Is, listen, I will write code for that. Sir, what is the function name I am taking? Something like insert at last. Insert at last. Sir, now first I am going to check. Sir, we are going to create a new node. New node is equal to, so node of, what is the data, sir, that we are taking? 50. So if head is equal to none, that means head is equal to none means what? We don't have any elements in the
Empty
linked
list.
list. Empty list is there. If the list is empty, whatever node that you created, it will become head node. Whatever node you created, that will become tail node and return the control. This is the first case. When this one is going to be happen, when you are creating a new node, that is the only node that we are going to take in the list. Already no nodes are there in the linked list. In such cases, what will happen? Your head will become none. So just for your understanding purpose, I am telling, sir, even if you are unable to understand, just ignore this topic. Don't worry, we will discuss in detail in our linked list chapter. Why I am demonstrating here? Because it is a demo session. That's why I am focusing. Okay, sir, clear up to this? Is the first case, is it clear?
Yes, sir.
Sir, otherwise what we have to do? Sir, I need to do two activities. What is that activity? Is already tail node is there. Can you please change tail node next field to new node? That means what? Sir, here this tail next node is already pointing to none. Can you please connect these two? Sir, after connecting these two nodes, now my question is, can you please tell me, after making the connection, which node should be tail node? Is it 40 or 50? Tell me, sir.
50, sir.
50. Why? Because Whenever you are inserting a new node at the ending, that newly inserted node will become last node, right? So what we have to do, you need to bring this tail pointer from here to here. Okay, we need to bring this tail pointer from here to here. So because we are performing which operation? Something like insert at last. Sir, how to connect this? Very simple. We have already name is there for 50. What is that name? New node. Sir, can I take tail is equal to new node? That's all. Automatically you can stop the process. This is the code what we have to insert a new node at the ending. Sir, everyone feeling comfortable up to this?
Yes, sir.
Yes, please
So, but
confirm
there
everyone.
are some edge cases as well, right? So we have to consider that as
How
well.
many edge cases will be there? Here only one edge case, right? What is that edge case? If the linked list is not, I mean, if the lists are empty, then only we have to look into that. 1 second. Sir, 1 second, please wait. Yeah, sorry for the delay, sir. Yes. Anyone tell me, someone is asking the question. Some conditions we have to check. Can you please tell me what is your doubt now?
Yes, sir. So I have sent in the chat box. Is it visible to you?
Yeah. Current node is equal to self dot head, while current
So,
dot next is not equal to none. Which code, sir? This one?
so basically, the first I am saying that we can declare this head part as current node.
Hmm.
So current node is equal to self dot head.
No.
So then
Okay,
we'll.
I understood the code, but what
Hmm.
is the purpose of this code?
So basically, I want to see if there is any edge case, because once we go to 40,
Hmm.
so then we'll see if it is not equal to none.
Hmm.
So if it is none, then we can add 50 to it. So
No.
finally, it will
Okay.
be
It is okay, but you are telling that if there is no name for the last node, here I have given name for last node, right? So if you
okay.
have a linked list, we have two names are there with our hand. What is the first name is head, which is always pointing to the head node. Okay.
Right.
So another node is nothing but what? The node which is
Tail.
not pointing to the first, I mean last pointing node, which is nothing but a tail. Because we have tail node is there, simply we can able to add. Got it? So what is
Okay.
your question is, if a tail is not there, then what will happen? Then whatever code you have written, that is correct. For example, consider here I am going to take the same story. Assume this tail is not there. It is also a
Okay.
linked list. We have only first pointer is there. Okay. Now see how I am going to write code for this. Now the program is the same. The program is the same. So new node, if head is equal to none, head will become new node. There is no tail. Okay. Up to this code is the same. Got it?
Yes, sir.
Now what we have to do, I am taking some temporary node which is pointing to the head.
Okay.
So I'm taking one temporary node. Parallelly, I will explain with the diagram. This is the temporary node which is pointing to the head. For short form, I use T, which is pointing to head. Next, I will write a loop so that this temp should move up to 40. So we have to take loop, right, until temp dot next is not equal to none. Sir, what I am going to do is temp is equal to temp dot next. Now see, first condition is what? Is a temp dot next field. Is it not equal to none? Yes. Then what we will do? Temp is equal to temp dot next. Now this will become temp. Since it is a while loop, again it will check. Is a temporary node next field is not equal to none? Yes. Then temp will become temp dot next. Is a temporary node next field is not equal to none? Yes. Temp will become temp dot next. Is a temporary node next field is what? None. It will stop
None.
the loop. Got it?
Yes, sir.
Now we
Got
have
it.
a name of this pointer, a node, and we have a name of this node. Can we connect each other out of this
Yes,
loop?
sir.
After coming
Out
out
of
from
this
this
loop.
loop, so temp dot next field will become which one?
New node.
New node. That's all.
Yeah.
Now what we are doing? We are breaking this new node. I mean next node is none, that we are going to break, and this next field is pointing to newly created node. That's all. Got it?
Correct. Okay, got it, sir. Yeah, thank
But
you.
how much time complexity is going to take? It will take a big O of n. Why big O of n? If your node contains 100 elements, you have to move how many
Traverse
pointers?
through.
10 times, 100 times you have to move, right?
Yes, sir.
Instead of that, one extra space is sufficient, right? That's why we will make this node name as a tail from the beginning. So that what will
Okay.
happen? Instead of writing these, so simply we can write the code saying tail dot next is equal to new node. We are not required to create any loop, so that we can reduce time complexity. Both are correct, but in this case unnecessary traversing is required. But here by giving an extra name, maybe space wise one unit it may increase, but when compared with that, this one will take more time, right?
Yes, sir.
That is the
Right.
solution. That's all. But your code is also correct. Got it, everyone? Please confirm.
Yeah, yes, sir.
Thank you, sir.
Yeah.
Right. So with this, I'm going to stop today's session.